In this section, we're going to talk about how to measure chemical reaction rates. Now, moving forward, this is really only going to be important in the lab. Once we get into the second half of this lab, we're generally not going to measure reaction rates ourselves very often and just rely on data from the textbook. All right, so let's actually talk about measuring these rates. Again, this is a very, very similar picture to what we saw before. We have purple molecules, they're disappearing, they're being replaced by green molecules, and we want to measure the speed of the reaction. And this is literally how we could do it. In the chemistry lab, we can actually measure the color of chemicals, and as that color dissipates, or as that color increases, we can actually measure the speed of the reaction. We can measure approximately how many molecules there are and use that to get a pretty good definition of rate. One of the things you'll notice right off the bat with these reactions is that they all appear to be slowing down. They go very, very fast. So that line drops very, very quickly at the beginning as reactants disappear, but then goes much, much slower at the end. And that's because we have fewer chemicals. Fewer chemicals, fewer collisions. Fewer collisions, we are going to form fewer products. And so the reaction is going to slow way, way down. So it's a good example of why knowing collision theory really helps to explain what we're seeing. So when we look at data that's collected over a chemical reaction, what we're going to get is the molarity periodically, in this case every 5 seconds, of both the reactants and the products. Now, what's annoying about this data is that we're not getting the actual reaction rate at any point in time. What we're getting is the average reaction rate over those 5 seconds. And averages can actually be quite a bit different from the real reaction rate, which is the exact rate that's occurring at time 0 or at time 5 seconds. And so we have to kind of be aware of that. We're not getting perfect data. And that makes it difficult to get good kinetic data from these experiments. So what we will get from most experiments is the average rate of change over time. And we should mention that this is the average rate for NO, right? We are talking about the specific chemical we are measuring. We will talk about standardized rate and what that means more in the next section. But what we're doing is essentially the change in NO over the change in time, or the delta NO. And it's worth mentioning that delta always means final minus initial. So make sure that it's always final first minus the initial. And because we have the concentration of a product, that concentration should increase over time. So we end up with a positive 1.56 molar per second rate for NO. And it's worth mentioning that if we used a reactant, that number would be negative because the reactants are going down over time. Okay, so let's do this as an example. I got rid of the micros because that's annoying. Let's look at the average change in NO and N2 between 15 and 30 seconds. And we'll go through the answers in just a few seconds. Okay, so change in NO, we're going from 0.270 to 0.2. Again, final minus initial over 30 minus 15 gives us 0.070 molar over 15 seconds. It gives us a rate of 0.00467 molar per second. We can do the same thing with N2. Again, we are doing final 0.035 minus initial 0.070. That's going to give us a negative 0.035 molar change, right? Which means this whole value is going to be negative. So 30 seconds minus 15 is positive 15. 0.035 divided by positive 15 gives us negative 0.00233 molar per second. So right off the bat, we've noticed a problem, right? Measuring different chemicals gives us different rates, right? And that's because we're not measuring the rate of the reaction. We're again measuring the rate of chemicals. And when we do that, the other thing we're going to notice is the reactants disappear, the products appear. So measuring this reaction in different ways is going to give us different answers. And what we need to figure out is how to streamline those and how to standardize those so we agree on what the speed of the reaction is.